So, first of all, welcome to the mock interview. It's always great having people come on, and again, thank you for accommodating my timeline. I know it was I know we changed times a couple of times, so sorry about that juggle. It's a lot of stuff going on right now.
Oh yeah, no problem.
All right. Getting into this thing, so just to clarify that the structure. This is going to be a mock interview. It's going to be an hour long, from 10 to 11. Typically speaking, in a real interview, they'll have some more, stuff at the beginning, introductions and whatnot. We won't be doing that. We can get right to the meat of the problem. At the end, we'll have 10 minutes or so. I'm going to aim for 10 minutes or so for questions, maybe 50 minutes. Okay, 50 minutes for questions, feedback, etc. Okay, you're asking to turn hard. I'm going to have you control the time. Okay, so you got to look at the time. You got to figure out leaving 10:15 at the end. Okay,
Sounds good.
and that's going to be typical as well. Usually they'll give you like 5 minutes introductions, that kind of stuff. I know you'll be doing like 40, 45 minutes of coding. So regardless of what it is, it's still going to be your time control here. Okay,
Perfect.
so let's get into it. So this problem, is Python okay for you? We can change the language here if you prefer a different
Yeah,
language.
Python's fine.
Okay, great. So how this gonna work is I'm gonna dictate a problem. You're gonna take some notes, write it down. You're free to stop me, ask any questions for clarification, and then whenever you're comfortable, we can get into it. Okay.
Sounds good.
Okay. So this is a problem, which I would like you to write me a function called bipartite check. Okay. The input is gonna be a graph, and the graph will be and the graph will be represented as a list of integer,
List of integers.
list of integer. Yeah.
Okay, so it's like int and then int like that.
Yes, yes, that's
Okay.
correct. And it's going to be simply an adjacency list.
Mhm.
So that's the graph, and I would like you to return true if and only if this graph is bipartite.
And so could you I haven't really I don't know really what bipartite means for a graph. Could you kind of
Yeah,
explain
no
to me?
worries. I'm happy I do. So a graph is defined as bipartite if you can split all the nodes in the graph into two non-overlapping sets. So let's call it sets A and B. Okay, so every node must be in either set A or B. There can be no node in both sets. There can be no node in neither set. They must be in exactly A or B. Okay, and the rule is
Mhm.
that every edge must connect a node from A to B. So there cannot be any edge that only goes between nodes in A. There cannot be any edge that only goes between nodes in B. Every edge must connect a node from A to B, or vice versa. This graph is undirected, for the record.
Okay, so it's if you can split all the nodes in a graph into two sets, right? And then
Yes.
they all have to, but each one has to be connected to one in the other set, like eight, like for example, here's like a A, right?
You can use the drawing
Or
tool if you prefer. It might be a bit easier. Up
oh,
to you.
it does it. Oh, it has it. Oh yeah, can you see?
I can see. Yep.
Okay, so from what I'm understanding, there's like these these nodes in a. This is a graph. Let's just say this is a graph, right?
Yeah.
Okay, so and and there should be two. Hold on, I think there's one more here. Yeah, okay. And there's like two sets, right? So this is one set we could say, right? And this is another set. Is that is that fine to assume?
Sure. Yeah.
Or
We can. Yeah. That's fine. It's however you want to draw it.
okay, and then or this is the whole graph, but these are just the two sets that we just I'm just saying it is.
Okay.
And then um all this these can't be connected to each other. These sets of nodes.
Sorry. Can you say it again?
So these you see this
Yes.
set
Yeah. The left
of
side.
nodes.
Yeah.
Yeah, the left set. This must all these nodes must be connected to a node in the other set, right? In set B.
Not quite. The definition is that there exists such a way to split these nodes. Let's say we choose a current split,
Mm-hmm.
such that there's no edge that goes between a node in A and A, and there's no edge that goes between two nodes in B.
So there's a way that we can split it where, so let's say this is one set. There's no node that, I mean, there's no edge that exists like this, right?
Correct. That's correct.
Okay, but anything else is fine. Or there should exist this one. This edge.
The definitions that what I can say here, the level of help you'll get is this: the definition of bipartite-ness is that there is no such edge that goes
Mm-hmm.
between two nodes in A, and there's no such edge that goes between two nodes in B. If those two conditions are fulfilled, then the graph is bipartite.
Okay. Um, could you actually write this out? Because I can't really fully remember it.
Okay, I can write it down in the notes for you.
Yeah, that's fine.
This is one way to define it.
Okay, so a graph is bipartite if the nodes can be partitioned into two independent sets A and B, such that every edge in the graph connects a node in set A and a node in set B. So yeah, that means that then from what I understand,
Mm-hmm.
there can only exist edges where they're connecting each other. So
Correct.
only these. Or like, and you said it was undirected, right?
Yeah, that's right.
Okay, so we have to check a graph and see if only these exist. Okay.
Mm-hmm.
Let's see. And we're given an adjacency list. So let's kind of run through this. One sec. So here we have like adjacency list, right? And we'll just say like 0 connects to 1, and then 1 to 2, or yeah, like this, and 2 to 3. So let's say we have this right here, right? This is four nodes and 3 edges, right?
I see 6 nodes.
One sec. Okay. Wait, I think I might have like represented it wrong, but it was supposed to be that this is 0, this is 1, and this means 0 to 1 means that this is connected to this. 1 to 2 means that this is connected to this, which is this is 2. And then 2 to 3 means that's connected to this. That's kind of what I wanted to represent. So this one being 1, this one being 2,
Okay.
3, and then 4.
Okay.
Okay, and then what we have to write is something that checks whether this this graph is bipartite, meaning that a certain array. Wait, hold on. Let me just reread this. If a node can be partitioned into two independent sets, it's at every edge in the graph. Okay, so, and we have to check if this can be divided into two sets, right? So, like just yeah, two independent sets, and the condition here is that every, let me just reread this. Every edge in the graph connects a node in set A and a node in set. So basically, we have to arrange this somehow so that they basically just only connect to each other and not to themselves. Or like to their own sets, right?
I think they said it backwards, but I think you might understand it. But I think they said it backwards.
Oh, okay. So they can only a node in set A can only have can only be connected to a node in set B.
Yeah, that's right.
Okay.
So is this graph here that you drew? Is this graph bipartite?
No.
Why not? Can you? So
because
yeah, go ahead.
okay, actually, wait, let me check. So let's split this into. Let's see if we can find a set or two sets where um they don't connect to each other. So, or and wait, this is the directions is wrong, but
It's not directed. Doesn't matter.
yeah, yeah. So I think that actually might be like the set of these two, right?
Okay.
They don't a set of, let's say this is node 0 and this is 4 or 3, then yeah, it exists these two sets, and they don't connect any of themselves, but they always connect to the other. But over here the problem is that this is not one because these are connected to each other. But this would be bipartite if it was like
Yes,
this.
that's true. But the original graph.
Okay.
Yes, yeah, exactly. So yeah, this is bipartite. That's correct. If you delete that edge.
Okay, so I'm kind of trying to think of a programmatic way
But
of
hold on. You
checking if
deleted an edge. If you don't delete the edge, is the graph still bipartite?
no,
Why not?
because if we take that as a set, then if we take that as a set, then there are these two nodes in the same set that connect to each other.
Yes, but why are we taking that as a set?
I don't know. I kind of just did it random. Let's see if
Okay.
maybe it's like a 1 to 3 kind of thing. Like uh,
It's not just. It's can you find a set? Can you find such
yeah.
a
Oh, so it
split?
doesn't have to include the entire graph.
No, it does have to include the entire graph.
Okay then.
But there's more than one way to draw the sets.
Okay, let's see. What do you think? Are you saying that there does exist like a set in here that could be bipartite?
Yes. It's by the way,
Okay,
it's not a
let's.
set that's bipartite. It's is the graph bipartite. Can you
Okay,
consider? So let me draw it here. So can you consider? I'll use this color. Can you consider this being in a set? So let's call this set A.
oh yeah, that's a set.
Okay. So let's call that set A. Okay.
Mm-hmm.
So
Oh, wait.
so if
Then
we call that,
doesn't there
let's
always
call that
exist a?
no,
Oh
not
wait, never
always.
mind.
Let's call this set A.
Mm-hmm.
If we assume this graph is bipartite, what is this? What does it imply about this node?
That 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 node is its own set. Or-
So if the graph is bipartite, that means that this node, the bottom node, must be in a different set than this node because they're connected.
Oh yeah, yep.
Okay, so we call this node set B. So this node is set B. What does it imply about this node?
Uh, that that node, since it's connected to set B, is its own independent set.
So again, the definition of bipartite-ness is that if you have two nodes that are connected, they must be in different sets.
Yeah.
So that therefore this node must be in set A. Does that make sense?
Oh. Okay,
Okay.
yeah. I get it. Yeah.
Is this graph bipartite?
Yeah, I think I was. Yeah. So if we have a set of these two, then it is.
Yep.
Okay. Yeah. Thank you for that explanation. I kind of I understand it now. Okay. So then I'm trying to think of a programmatic way of doing it, right? So we could start off like a greedy approach of just saying that this, whatever we start off with, is a is a is a set of itself, and then if if and we only need two sets, right? So if anything exists, or if there's if it's connected to another node, then we have to just consider that to not be a part of the same set. And then what if that is connect if this B is connected to another node, then we have to consider that not being in the other set. But we have to check for that, right? And
I
then
mean, you tell me.
so if yeah, I'm kind of just speaking out loud. So
Yeah.
so if this does exist, then we would check if this is in has any is connected to any nodes that are in the are are in set A, and then if it is, then the, then um hmm. 'Cause I feel like this is kind of like a linear approach I'm taking, which doesn't like it's not think about the entire like scope of the problem. Like I feel like there's like what if uh well for now I'll just think about it like this. So we have to check if this um is connected to any node in set A, and if it is, then that graph can't be bipartite, and then if it isn't, then it can be. Think that's a naive approach or a naive thing to say?
Mm-hmm.
Pardon?
Yeah. Okay.
So you think so?
That's definitely an approach you can do. Yeah.
Okay. So I'll kind of write out what I'm thinking of doing, which is create two sets. Uh, assume the first node. I'll kind of like exit out of this. Node IC is a part of set A, and therefore any nodes or any nodes connected to it are in set B, but um but if the node connected to it is connected to a node in set A, or wait, then I think it's too wordy. I kind of got confused, but we make two sets. We
Yeah.
assume that the first node just arbitrarily is in set A, and therefore any nodes connected to that node should be in set B, but um we have to check if it's connected to any node in set B. That's what it is. Okay. And if it is, then return false cannot work. Okay, I think I get it. So here we have a function, and I'm just gonna. Okay, yeah, we have a function, and it's gonna be check bipartite. Okay, and then you said the input was just the adjacency list, right?
Yep.
Okay, so I'll just call it this, and then it's just it's just kind of like the example I showed here,
Okay.
right? Like in the drawing with
Yep.
just list, and it's bi-directional. Okay. Okay, now um we can do this. We can do set A or A equals a set, right? And B equals a set. Okay. Okay, so now that we have these two sets, right? We're gonna just okay. So we make the two sets, assume the first node in the adjacency list is a part of set A. Okay. So we have this adjacency list, and we're gonna say that the first node is a part of set A. So let's do like it 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 uh hmm. Okay, I'm just gonna add. Are will it just start with 0, or it could just be like um all right. Okay, so ADJ. So here I'm assuming that the first node that we got, which is this, is a part of set A, and therefore any nodes connected to it are in set B. Okay, now I think before I have to write that check function, right? Which will check if um oh, I see. I think one thing might be that if I check too early, then I might be missing some stuff. Or actually, no, I won't be. I might. I'll just see at first. Okay, so here I'm gonna make a function to just check, uh, and then we're gonna have let's see. Yeah, we're gonna have it's gonna take in a node, and then it should check if this node is connected to any node in uh in set B. Okay, so what it's gonna do is gonna do for from to in adjacency list or in yeah adjacency list from let's see, what was it? Yeah, node. So I'll do like this. And you kind of understand where I'm going with this?
Uh, I think I get where you're going to. What is node here? This is an index of the current node you're checking.
Yep, that's
Okay,
it.
okay. Um,
And go ahead.
what type is your adjacency list?
Uh, well, it's just a list of lists.
Yeah, it's a list of lists. So, what type is adjacency of an index?
It's a list.
Okay, and how are you planning to navigate? Like, what's the types here?
So this is the edge between the two nodes.
Oh, okay.
It's
I
saying
think
like it.
yeah. So, what this is not an adjacency list. This is an edge list. We have an adjacency list as an input.
Wait, adjacency list and edge list.
Yeah. So you're thinking of this as an edge list. That's not an adjacency list. The input's going to be an adjacency list.
Okay, so what's I see. Yeah. So it wasn't actually like the example I showed. It was something else, right?
Correct. Yeah. The example you said that you're doing a shorthand, so I thought you knew.
Okay, yeah. Okay, I get it then. Yeah. So instead of that, it's like for let's just say I in adjacency list, and then it'd be like let's see. So then this is just everything that this node points to, right? Or is connected to.
Yeah.
And so um let's see. So if it's everything that is connected to, the way to check uh would be to just okay. So the edge would be node to I and then I to node because it's bidirectional, right?
Yep. It's
Okay,
bidirectional.
so let's. Mm-hmm. Okay, I feel like for this I can do like yeah. Okay, I'll just continue. So I get the node right, and then I have to. Uh, Okay, so I get this node, and then I have to go through it for all the things connected to. So for I in adjacency list at node, and then I have to go through this and see if any of those are in set B, or I think it would be like a BFS actually. Um, so So I'll just add like a queue, you know, a DQ. Should I import it or
You can import it, yeah.
okay? So we're gonna have a queue, which is gonna be a doubly linked list. And what I'm gonna do is um, just append the current node to it. So queue.append node, and then it's gonna be. Am I the one highlighting this, or is it you? Never mind.
It's you.
No, I'm pretty sure. Because this is me highlight. It's fine. It's fine. Okay. Now we're gonna pop from the queue, which is let's just do like whatever. I'll just call it cur equals queue dot pop left. And so what I'm doing here is I'm getting the current one, and then now I'm gonna check all its neighbors basically. For I in AG, I keep on misspelling this. ADJ. So everything adjacent to this current node, or current should be the okay. Now how do I check if it's in the sets? Oh, so this one should check if it's in set B. So if let's see. So if I in B so it's I's in B, then what? Okay. If I is in B, then and let me just reread my thing. But if a node is connected to a node instead B, then return false. Okay, so anything connected to this. Okay. So if this I is in set B, then there's let's see, what would be the problem here if it's in set B? If it's in set B, then return false. So I guess we're checking for anything connected to the A, and if it's in B, then it's false. So like return false. And then if it's or return false. Okay, and then if it's okay, so now it was connected to a node in set B, then it was false. So now we have to if it's not connected to that, then it's a part of set A, right? So A dot add I, and then we also have to enqueue it. So like queue dot append I, and then we have to check if this current one is in in set B, I think.
The current one is this one or this one?
Or like wait. So we basically what I did was to for so this would check if I is in set B, right?
Okay.
And then if it is in set B, then um that can't that won't work basically because I don't know where this thing got important. Um, that wouldn't work because then a node in set A is connected to a node in set B,
Okay, and then
and
what does
then
the okay and the a dot add?
here I'm adding it to this to like this A set, and then here I'm also adding it to this queue to check if that node that is in set A is connected to any node in set B. Uh, wait, I'm not I'm not adding anything to set B, which is gonna be an issue, I think.
Mm-hmm.
Um, yeah. So if okay, so okay, wait, I can just add this to set B. The thing is, I'm pretty sure this is not right actually. Oh, I was gonna add like the thing connected to the first node that we assume is in set B, but I think that's a little too naive. Let's see. I'll just go with it for now, but I think I'm gonna have to find like a way to populate set B. Uh, okay, wait. Let's see if we can find something here. So we're popping left and we're checking. So if this was connected to a node that was in set B, then that would be wrong. And then if um hmm oh, I can just do this like one and then somehow populate set B with uh um hmm. Like I was thinking of kind of just going through
Okay.
both of them like huh
Are you currently
hmm.
more confused about the initial setup, or are you more confused about the algorithm?
the, so I'm pretty fine with like I think the algorithm which
Okay.
I think I've kind of gotten here like not fully but the initial setup of populating set B I feel like
Okay.
I'm missing something there.
Okay. Well, if you look at the drawing again. Okay, so
Okay,
look at the
let's see.
drawing up. We have. I mean, let me. So you didn't write the numbers. I'll write the numbers for you. We'll call
Thank you.
this node 0, 1, 2, 3. Okay.
Mm-hmm.
So what should we initialize set A with?
Just zero.
Okay, and what have you done?
I initialize it with zero
Have you though?
or the first thing.
So what is the? So that's actually what the adjacency list does. So let's ignore that. The adjacency list for this would look like if you have a list. Inside a list, we have what is A connected to A is connected to 1,
Mm-hmm.
and what is node 1 connected to? It's connected to 2. What is node 2 connected to? It's connected to 3. And what is 3 connected to 3 is not connected to anything.
Okay.
This is what your adjacency list looks like.
Oh, okay. Okay.
Does that make
Um.
sense?
Okay. So an adjacency list is um, for example, at here at index zero, I is one is connected to. Okay. Okay. And what I've done is um, I think yeah I still kind of assumed that as actually the edge and I mean an edge list or what the that's what you said, right? An edge list. That's what I kind of assumed it as that.
Mm-hmm.
Okay, yeah. So then this initial setup is not right. It should actually just be zero.
Okay.
And then this should be uh like everything. It's like I for I in adjacency list zero. Need to add one more. Okay. And then this, I think this should be an array.
Yep.
Okay. So the initial setup is this. Okay. And okay. Now I think what I can just like uh what I can do is go to like just go through everything in B. Oh, honestly, it doesn't even need to be a set. Or actually, that's fine. So what I'm gonna do is I'm gonna go through everything in B, and if anything else is connected to anything connected in B, then that should be a part of A. Or yeah. Uh yeah. Okay, so um okay. So what I'm gonna do is okay, so I've initialized this to 0 and this to all of it is connected to 0. So I'll do this. Or I'll leave this, but I'll do this too. Q dot, or I'll just make a Q again equals DQ, and then it should have just 0 or 0, and then I'll do, or I'll okay, I'm just basically just gonna do this. Okay, so I'll just send in check 0 first. Just to visualize it. So check 0, and what it should do is, I guess it should be like that. Okay, but what it should do is traverse everything in the set, and it should add it to set A. Okay, so I'll just go ahead and do that. So okay, so it adds the node while Q pop left for I in adjacency list. In adjacency list, it should yeah. So it goes through it, and it shouldn't even check that. It should be like okay, so we go through the adjacency list, and what do we do here now? Okay, for I and adjacency list now. Now that we have this, everything adjacent to this should be in set B. So then, should be like. I don't know why it highlights it, but if it should just be b dot add I, and then should be, what else? I don't even think there's any other checks. It's just it just adds them all to there, and then oh, it also has to enqueue them. So q dot append I. Okay, and then so what this would do is here we gave it 0, so it would add 1 to the set of B. Oh, I think there has to be like some way to alternate between them, because it would be like and I'll give it the set too. So set, and then it'd be like B, and or or I think it should just be like this, like B, and then it'd be, instead of cur would be cur, and I feel like I've kind of messed up like the setup of this. Uh,
In which way? Do you mean like
like I feel like the initial setup of this is kind of is wrong.
okay.
Uh,
You should probably continue with your current implementation.
okay, so this set, and then we just do set dot add, or I think I just changed the name to like s. Okay, and then it's s dot add at I, and then q dot append I, and then it should be I, and then it should be like the opposite of the current set. So for the other one, so how would I do like with the just swap, or like if okay. So if it was originally this B, then it should be a A, and if it was a A, then it should be a B. Okay, I can like I can kind of just do this like like or cur equals 0, and then so if it's divisible by if this number is divisible by 2, then, or if it's even, then it's B, and if it's odd, then it's A. So now we do if cur divisible by 2 equals 0, then it should be B. Oh, it's like B if else A, and then B. One. Oh, and then it's like another way. Okay, and then this will flip flop between them, and 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 add them to their appropriate set.
Okay.
Does that make sense?
Yep, I think so.
Okay, and so when this is ran, I'll look at the image over here. So I give it 0, right? So
Yeah.
so it takes this 0, and it checks all its adjacents, everything adjacent to it, and it adds them to set B. So it adds 1 to set B, and it takes this this 1, and it checks all its adjacencies, which is just 2, and it sets that to set A, and it looks at 2 and checks all its adjacency, which is 3, and it puts 3 into set B, and then since there's nothing else after 3, it should put them in their appropriate set.
Okay.
But I think actually there might be like an issue here, which I'll do. I'll check if cur divisible by 2 equals 0, then um, b equals s, and then else a equals s. Is that fine?
We can proceed with that.
Okay, and let's see now. And then so now it will add them to their appropriate sets, and uh, now after we check this 0, um, okay, now that we check that, mm, you could just do like a check like this, like so for I in A, if any in adjacency of I in, or oh, if any for I, or for J in adjacency I in B, so if, or if any, or wait, so if anything adjacent to set A is in set A, then return false. What is this expected expression? I think it might be something like this. Okay, so if any of this is in the other one, then that's wrong. And then, wait, where? How is this I not being used here? The scope of it. Okay, and then.
Wait, what are you? Sorry, what is this trying to do?
So what this is trying to do is it'll go through everything in set A, right? Now that we've populated everything. Okay, so it'll go
Go
through
through.
every
Okay.
single. And I think it might just be like a list A or something, but I haven't really done like DSA in a long time. I did it like a lot first year, but I kind of stopped after. But um, or so or at least Python, and so I'll go through this. It will look at everything adjacent to uh if it'll see if anything adjacent to itself uh, is also in the same set, then that means that's wrong, right?
If everything adjacent to itself is in the
Or if
same set.
anything adjacent to itself is in set A, then that's wrong.
Yeah, yeah, that's true. Yeah, that's true.
Okay, and then um, I'm pretty sure we don't even have to check both. I'll just check anyway. This probably is. I'm pretty sure we don't have to, but or actually, we might have to. Yeah. If in list B, in set B, then that's wrong. And then if these none of these return false, then we just return true.
Okay.
And yeah, I think that's about it.
Okay. We're out of time today, so I'll just quickly go over the time and space with you. Do you wanna have a go at that?
Yeah. So this is basically just it's basically a BFS, right? So it's just O of n space and then I mean time and O of n space. It's a multiple of that. Because I think I create like
Okay.
a random space memory thing here.
Does okay? So can you say the complexity of BFS again?
It's O of n.
What's n?
N is the size of the entire like adjacency list. It'll just basically go through all of it.
Size of the
Wait,
adjacency list. What's the size of the adjacency list?
wait. Never mind. Never. It's n squared. N squared. Mind.
Okay, and what is
In this
n? In this the size is in like how many elements are in it? It's a list of lists. Keep that in mind. What's n?
N is like the number of lists.
Number of
like
lists.
so it's a list of lists, right? So it's just
Yes.
the len of the adjacency list.
Okay, so len of adjacency, basically saying. Okay.
Yeah.
And then what's the space? By the way, sorry, was that time for just a BFS check or including everything else here?
These are just these are also like n squared, so it's just n squared overall.
Okay, and then what's the space on this one?
The space. I mean, just these create n squared space, so it is n squared, I think.
Okay. And n is also the length of the adjacency list.
Yep.
Okay. I should actually just put these over here for the notes. Okay, so that about wraps up the time we have, but for the mock. But we have time now to go over some feedback and questions. So why don't we jump there?
Sure.
I'll go this up usually by asking the candidate, how do they feel? What do you think went well? What do you think didn't go so well? Quick, like 20-second summary on that. What's your opinion?
I'm pretty sure this is not like the most optimal solution. I feel like I kind of had too many early assumptions, and at the beginning I didn't I might have assumed a little too much. It's like I started off wrong, and I didn't fully, or I kind of just assumed it was edgeless, but it wasn't.
Okay, yeah.
And also I think yeah, it took a long like 10 minutes or so to like fully grasp the question, which I think was not good. And also I didn't have like a clear plan of how to go about it before I started.
Yeah. Yeah. I think that's fair. I think another thing there is there might have been a bit of confusion / lack of direction on that front, but we'll break that down a little bit. So, okay, so top level kind of comments here is this problem it's a Leetcode problem. It's testing whether a graph is bipartite. You won't really get docked marks for not knowing the definition of bipartite-ness. That is not assumed, especially for interns, really. But it is expected that after the definition provided, you can understand everything completely. So that would be the level of difficulty for this problem, basically, right? Definition of bipartite-ness was so I actually gave it two ways. The first, so there's a positive way and a negative way. The positive way is what ended up being written. So that's the positive definition. The negative definition is what I said, which is instead of saying that every edge is connected in A to B, it's that there cannot be edges from A to A and cannot be edges from B to B. So it kind of depends on your preference there. Gave it both ways. Looks like he preferred. It looks like it was the same for you at the end. But do note that it's expected that you should be taking notes on that part and for you to clarify the requirements there. So that took more time than what was probably expected for this kind of problem. Understand the problem in the first place. A pretty major hint that was given was about what we call the traversal. So in this case, me drawing out the specific explanation for going from A to B to A, etc. That is the algorithm that you should be following essentially. That was given. I didn't see make progress on that, so I just gave it to you and just to test. So I mean, I gave that as the proposal because I wanted to see the implementation skill at that point, right? So first it's okay, do you understand the problem? And it's okay, can you think of an algorithm? And it's okay, let's see you implement the algorithm, right? So be aware that when interviewers give you hints, they're likely just telling you to okay, move on.
Okay.
Right. So that part was good. At least when the hint was given, you understood what was going on. And you drafted a proposal here. That was pretty good. Like you said, misunderstanding of an agency list. Just clarify that ahead of time. Especially if you're spending time to draw stuff out, just draw out the input as well. There's no harm in that. It wasn't until you got to the original implementation here, somewhere around here, where I said, "Oh, you clearly don't understand what a adjacency list. I have to clarify that." Right, but you should clarify that earlier before you start implementing. Otherwise, you could have dug yourself in a deeper hole, right? So just clarify
Yeah.
that. There was some going back and forth. You were deleting and rewriting some function like check at the beginning. You were kind of deleting it. You're writing some stuff there. Again, right?
Mm-hmm.
Have the plan out, like you said. Have the plan out before you start writing. Otherwise, it's going to look really messy for the interviewer. They're not going to be able to follow what you're trying to think and trying to go through. So just be clear about that, right? If you keep deleting, keep rewriting, that's bad luck.
Mm-hmm.
Um, Original implementation where you didn't swap the sets, that was definitely confusing as well. You did sort of catch it by saying, "Oh, you're never adding to set B." That was a good catch, but it was not. But like typically speaking, if I would expect that if you make that catch, it would have been immediately okay. We just swapped the sets, we swapped the set, etc. So
Yeah.
that took maybe a bit more than it should have to kind of get to that conclusion, but you still got there. So that's
Mm-hmm.
something. Um, yeah, and then again, the when you identify that the adjacency list understanding was incorrect, you didn't go back and fix the sets. I would say in general, when you're corrected on something, you should be looking through your entire solution and seeing where else it would have been wrong. Okay.
Yep.
Typically speaking, if you made a false assumption up to that point, that will affect more than just the one area where the interviewer gave you a hint.
Sounds good.
Um,
Yeah, I'll just write this stuff down right
I have the notes. I'll send in notes after.
now. Okay.
Okay, some other stuff here. Some quick stuff I wanted to get through as well. The BFS has a bug where it might not terminate. In fact, it won't terminate. So you need to be careful about that. If you have a BFS
Mm-hmm.
template, you should be referring back to the template and kind of modifying that. If you write the new BFS every time, you can run into these sort of bugs, right? So just keep that in
Sounds good.
mind that your BFS here wouldn't terminate if there's a cycle.
Oh yeah,
Um,
you're right.
yeah, time control here. So time control, you did run out of time at the end there. I'm not sure how much you're used to controlling that front, but if you're going to big tech companies, they're going to be expecting you to be able to know the time control on that one. So it will reflect. So while the interviewer will still guide you, it will reflect poorly if you're not the one leading the initiative.
Sounds good.
Okay, some bugs here. I mean, the syntax here is just wrong, unfortunately. I'm nothing for me to say there. You can search on your own time. I'm not gonna waste your time here. Um,
Yep.
and yes, you do need to check both lists. So it is correct that you need to check both. Um, an interviewer, if they have more time, they might ask you to explain why you assume you might only need to check one, and to catch that issue. But yes, you do need to check both. And lastly, time and space complexity is not quite right on this one. Generally speaking, you should be referring to the base complexity of BFS, which is the number of edges plus the number of vertices. So the number of edges in this, the number of vertices is, as you said, n. The number of vertices in this case can be up to n squared, but is not necessarily guaranteed to be. In which case, yes,
Mm-hmm.
that would be n squared. So that's something to clarify. Generally speaking, by the way, you don't want to use one variable, in this case n, to describe complexity for graphs, because edges and vertices are not correlated. So you
Mm-hmm.
need
Makes
two
sense. Yeah,
variables
that
for
makes
that.
sense.
So while n squared is technically correct, you didn't provide a correct explanation for it, so that would be marked wrong in that case.
Mm-hmm.
So just be aware of that. Space is also v plus z if you don't do it correctly, but if you don't explain it correctly. So yeah, just make sure you use two variables when you describe anything with graphs. Just make sure you do, and it could be more than two, but at least two, right? One for vertices, one for edges.
Yep.
Um, yeah, that's the high level review, and we have maybe a minute or two for questions. So I want to give a bit of time back to you if you have anything to say.
Um, I really didn't have any more questions to be honest. You kind of like um kind of explained it, but I was just wondering, was sets actually required like for this to actually be a set? Was that requirement? I feel
There's
like it.
many. So the way you s- the way so I mean sets are never required. It's just a thing to improve complexity. In this
Yep.
case, it would have helped because otherwise you would. Okay. So this refers to this part here. This is too wrong for me to honestly comment on. The way you should
Mm-hmm.
have done this, by the way, the way you have it set up should be, if I may, it should be return a NB. Well, this should be this is what you should. This is the correct answer. You don't need any of this. In this case, the center intersection is linear time.
Mm-hmm.
Is linear time. So yes, the set would have helped there if you use a list. This would be n squared. So yes, for your
Yep.
solution that would have helped. Correct. However,
Okay.
that's not the only way to solve this problem. The quote unquote optimal solution is known as what's doing an odd cycle detection. I won't get into that. You can search it up on your own time. It's a bit more complex. This solution is fine, by the way. DFS is fine. But if you were to do the optimal solution by using a depth first search with a spanning tree, or a special like a pre-order traversal of some sorts, that would be linear
Mhm.
time, and that would not require you to have a or B set. The A or B set solution is just a way to explain the problem in an intuitive
Yeah,
way. So in the way you've done it, yes, they do need to be sets.
makes sense.
Okay.
Yeah. I had another question.
Yeah,
Um, I think I heard that you worked at AWS before, right?
that's correct. Yeah.
And was it in Toronto
No, it was in Vancouver.
or Vancouver? Okay, yeah. I'm actually starting this summer. I'm gonna be in at AWS. I was wondering if you had any like kind of advice for me, like anything I should do before I start, anything to do to like, just hit the ground running. Because I know the pace at Amazon and like yeah, at Amazon especially is pretty fast, right? So I don't want to really be stuck doing like like the menial stuff or like the trivial stuff and kind of like just start off hit the ground running. So is there any advice you would give for me to prepare or anything?
Yeah, so I mean that's not an interview question, so I'm not gonna answer that here. However, feel free to tag me in the Discord channel. I can provide a more in-depth answer there. I am also currently writing a guide as part of TCN for people to prepare for their internships. If I just pull it up real quick, I mean
Hmm.
I can see if there's anything I want to say. Typically speaking, I will say you're starting the summer, which is soon. There's nothing you can realistically prepare in that time to actually help yourself, and
Hmm.
that's two things. The main thing is because you can't learn things that are technical in that amount of time. That's not worth your time. You're honestly better off preparing in terms of strategy,
Hmm.
right? So keep a high level. What is your goal out of it? Who are you planning to speak to? Who are going to be your contacts? What is your support network going to look like? That's more worthwhile to prepare going in than anything related to the job, in my opinion. So I'd say if you want more detail about that, please go ahead and tag me in the early career channel. That'd be a great way to get in line. And of course I can that way my response can help more people, right? But that's not
Perfect.
interview related, so I'm not gonna answer that question on this call here.
Yep, that's fine.
Well, that's all the
Yeah,
time we
that's
have.
about all the
So
questions
yeah,
I had.
thank you. Thank you for your time. Thank you for participating. Thank you very much. Take care.
No problem. Thank you. Thank you for the interview.